and then really get our hands dirty because, oh, thanks. Do we have to walk around with this the entire time?
That's the only way I know to get the audio to
Okay, cool.
go through the WebEx.
I think the audio goes again.
Yeah, okay, cool. So, yeah, like I said, we will give a small introduction about all the stuff we're going to do today, and then, yeah, basically it's mostly hands-on, because the only way to get going with this stuff is to really deep dive into it, get your hands dirty, and start building exploits, right? So, yeah, small introduction for myself. So I'm the security chapter leader in the ING Belgium. So that means we do like around 600 applications for the bank there, you know, from mobile applications to web to API and stuff like that. Yeah, you know, I'm a software developer from my heart. Do a lot of penetration testing like now since more than 10 years. Started like hacking when I was like 13 years old. I'm also doing together with him and the dev, so we do trainings also for companies and like this workshop session from OWASP to train people and build secure software. So that is a small introduction. Yeah, cool. So my name is Ricardo Tenkate. I am mostly a security consultant. I like to do what I do like to do most is to do red teaming and offensive stuff. But lately I'm also heavily into building security test automation into CI/CD pipelines and setting up the whole vulnerability management systems and stuff. Yeah, basically I don't have a cool background story like I started hacking like when I was 13 years old. 10 years ago my brother said you will start doing programming, I'll slap you silly. So here I am today. So basically what we wanted to start off with is cross-origin resource sharing. And yeah, that's a big issue.
Echo.
So you can basically see that's a really big problem. The cool stuff about cross-origin resource sharing or the misconfiguration of it is, yeah, it kind of works like the same way like cross-site request forgery, only except where with cross-site request forgery, you could do state-changing operations on the other user or on an authenticated user's behalf. With coarse misconfiguration, you can do XHR GET requests on an authenticated user's behalf, and with that, effectively, yes, steal sensitive information from an authenticated user. So that's pretty awesome, if you ask me. So normally, if you look at the whole core setup and how all that stuff works, so if you have, oh, that doesn't work on screen. Oh, no. So basically what you get is normally when you would send the access control allow origin, you can use a wildcard if you want everybody to access that resource, right? So what you're seeing that most modern frameworks have done is whenever somebody uses a wildcard for the access control allow origin, basically what happens is you cannot send the access control allow credentials headers with it because the browser says, and you have the same origin policy, the browser be like, nobody be dumb enough to set the access control allow origin on the wildcard and also append that header, right? So what all modern frameworks do is to do the dynamically allocation of the origin header. So they basically pick the value from the origin header, dynamically allocate that to the access control allow origin, and effectively, then whenever a request is being made, the access control allow with credentials can be set to true, and with that, we can do authenticated XHR GET requests on XHR GET requests on an authenticated user's behalf. Yeah, and with that, steal sensitive information from a web server from a web application. So, this happens all the time whenever I have a pointer and a microphone in hand, because I like to do this with my hands, but I don't really have the freedom right now. So basically, what the attack and what the payload would look like is normally kind of like this. So basically, as you can see, you also set the with credentials to true. You do this XHR GET request to the API endpoint you want to steal the information from, and as soon as the user is authenticated, and like I said, this kind of works like cross-site request forgery, but I will draw out in a bit how this would work in practice. Yeah, you can steal sensitive information from the web server. Super darn interesting. So basically what I will do now is I will draw it out on the board, give you some inside information. So who of you here knows how cross-site request forgery works? Okay, cool. So then I will draw it out. So you have to imagine, this is a shitty stift, shitty marker. Hmm? This is way better. So let's use our imagination. This is your browser. Yeah? So whenever you authenticate yourself, the application sets the session cookie, right? And the session cookie, you can imagine if you have, I can't draw like S, so imagine yourself, this right there is the cookie jar of the browser. So as soon as you authenticate, so you're, for example, you have yourself here. No, this is not evil yet, this is the bank. And you authenticate yourself there, your cookie will be stored in the cookie jar, right? Your session. So now your session is stored in the cookie jar. So basically what happens now is, let's say this bank has a form on it, which allows you to deposit money, withdraw money, or whatever. Use your imagination. So what the attacker would do is he would lure or do some social engineering and ultimately would lure his victim to his evil website. This evil website has the same exact form on it as the bank application. This form is hidden though. So normally you would put this in an iframe or whatnot, and as soon as the user gets to this page, this form will be submitted. And here's where the magic happens. Because the action of the form, so this form will be submitted super sneaky with JavaScript. But basically what happens is, the form has an action, right? And the action points to a source. So the easiest way to understand how this works is, whenever this form is being submitted, it goes through the cookie jar, and the cookie jar basically checks, hey, this request that's being made, do I know the domain the request is being sent to? As soon as the cookie jar recognizes the domain, it takes the request, slaps on the session cookie, and then sends the request to the banking application. So this is how cross-site request forgery works. This whole idea kind of also works for cross-origin resource sharing. Also, of course, with cross-origin resource sharing, you also have some pre-flight stuff and some handshakes, but it's kind of like the same way. So you have this bank, and instead of a form, you now have sensitive information, yeah? The browser does the dynamically allocation of the origin header, so that's all pickety-boo. So now the allow with credentials header is also being appended in this whole handshake, yeah? This pre-flight handshake is going to perform. And as soon as this request is going through the cookie jar, it checks if it knows the domain, yes. Is the header for allow with credentials set to true? Yes. Then it kind of does the same thing. So it looks at the request right here. So this is your headers, your post body and whatnot. It checks, do I know the domain? Yes. Okay, please then append this session cookie, go through the cookie jar, go to the banking application, and then ultimately get the site from the banking, or get the information from the banking application to the evil application. We'll see how this works in practice when we're going to do the hands-on stuff. But this is what goes wrong with cross-origin resource sharing and the dynamically allocation of the origin header. So that was all for now. So basically what we're going to do is we're going to describe all the topics real quick, give you an idea how the attacks work and what the attack factors are. So as soon as you guys and girls do the clone from the GitHub repository, you will also find the course outlines. So in the course outlines, every attack is described into details with all the steps in and how to effectively perform it. So it gives you the information to do the reconnaissance and to effectively get to the conclusion where to do the attack yourself. But yeah, if you get stuck, it also has step-by-step information on how to effectively do the exploit yourself. So who of you do have laptops? Yeah, kind of everybody, right? That's nice. Say the slide so you don't have a laptop with you? Oh, you have, yeah. And you have a laptop? No. Uh, if you want, you can also use this one. Yeah, your watching is good. Okay. Huh.
Back to my meat. Did I go over to the other piece? Back to the other piece?
Could be. Oh, we didn't have the fancy. We just have a paper one, so you need some. Oh, okay. Yeah. So wait a bit till everybody has some internet and is able to pull it. Nee, je kan alles alvast uitleggen. Iedereen kan ondertussen gewoon een spoor gaan poelen. Yes, if you go there, then you have the instructions. You can or use the Docker version, or you can just use the online instance. We also have an instance spawned up online. So if you go to this URL over here, so basically we have a hacking lab where we have vulnerabilities in. On this URL, what you see here, we have in the Google Cloud an instance of this vulnerable application. And in there are, of course, deserialization and a couple of like exploits we're gonna do hands-on. If you say, well, I want to have it running locally, then you can just go to the GitHub, and there you can pull the Docker image and run it or install it locally. It's a Python application. But if you go to the GitHub, you should have all the information there, what to do or how you want to use it. Ah, yeah. Yeah, okay, good. Question?
Has it started yet?
Well, kind of.
Hey.
Right, good. So let me explain the next topic a bit. It's about deserialization attacks. Who has heard of it? Okay, people know how to exploit it. It's a very difficult subject, if I would say myself, because you have different type of structures. Some of the deserialization attacks you think like, is this really deserialization? But when you focus on what is really the problem when these type of attacks occur, then I think you can easily see a connection. So basically, the deserialization, what is actually a problem? Like, for example, if you take Java, sometimes you want to have like an object that you have in memory and that you want to share to another application. And also use it in that running environment. You need to have like serialized objects to be able to send them over to each other and be able to load them in the memory of the other application. They're very fast, and you have a different type of format. So for example, JSON, XML, those both are like objects that are being serialized and deserialized. And yeah, like it says here, many program languages have native capability for serializing objects. Of course, where's the whole problem? When you have an object and that it's really being built by an untrusted data source. So for example, if you give the attacker the whole control over the object, yeah, then nasty stuff can appear. Yeah, and what can be the impact? You can bypass logic flaws, code execution. Also, the business logic, of course, can be affected. So it's quite impacting. Here are, for example, a couple of vulnerabilities even released, as you can see this year. All vulnerabilities, that have a deserialization issue, and mostly with these type of things, you can evoke them really easily because there's like a certain service that is being spawned by those type of applications that listens to serialized objects coming in. Well, and like I mentioned before, because we can craft our own serialized object as a whole, as an attacker, we can influence the logic or execute maybe code on the machine. So in the application we built, there are different types of serialization attacks. So we built two for you to practice. So we have one with, not going to spill too many details. There are two different types of serialization attacks in the target application we built for you for this workshop. Yeah. So one probably you wouldn't, think of it, but it's very interesting. Who of the people have working here with like YAML files and stuff like that, and GitLab runners and other type of stuff like that? So also there you have, that's one of the type of attacks you can abuse next to like the real serialized objects that you're can send. Like my brother said, we have a lot of information on the page, on the GitHub page. So there we also have some step-by-step examples, also specific to the workshop that we set up, that you guys will be doing some hands-on. Also, my brother and I will be walking around and guide you a bit and give some hints, so you truly can play yourself with it and do some deserialization attacks yourself. Like we mentioned, we're going to the 4 topics, the 4 different type of attacks we want to show, just to give a brief idea what it is, what the impact is, and a bit already some clues how you should approach it. The other thing we wanted to briefly discuss is the Surfside template injection. Again, very interesting vulnerability. You don't see it that often, but there are some specific tricks you need to know. How to search for these type of vulnerabilities. And again, that is what we want to. Non-compliant. Yeah, it shut itself off. Or? It dies, but you have to. Oh, there it is. Back up again. Thanks. So, like I said, we really want to deep dive into everything and do everything hands-on ourselves because, ultimately that's the best way to learn. We can talk for 4 or 5 hours about how all these exploits work, but the best way to learn is to do it yourself effectively. So basically, the whole idea and the whole problem with server-side template injection starts with whenever you're starting to use, my God, I just totally, templating engine. My God, I had the word on the tip of my tongue and then it flew away from my mind. So the whole problem arises when people are using templating engines. So when you are using user-supplied input and you render that as part of the template, then you open up a whole new attack vector. So pretty much all the templating engines really do a good job in preventing cross-site scripting attacks and whatnot. I really have to give a big disclaimer in this one because they know what a template expression is? Yeah, we'll get to that. Yeah, in a bit. Yeah.
Want to try that?
Oh yeah, cool.
Try and put that on
Delete. Oh, yeah. Okay, nice. Yeah, so, oh, this is really loud. Yeah, so that's basically the fundamentals about what goes wrong with server-side template injection. So basically, like you said, user-supplied input is being rendered as part of the template. And with that, yeah, the attacker can inject template expressions, iterate through all the self and other objects within what is provided by your template.
vulnerability, server-side request forgery. So using this, you can also jump to other machines and servers and do a sort of port scanning. Great way to get more access and foothold into the internal network that the server you're owning has all like a mutual connection to, like the backend systems and whatnot. So here we have an attack of the XXA. So as you can see, we have a doc type, so the header of the XML. In there we define a new entity with a variable, and then from the system we load a local file. That we reflect the variable in the XML tag, and we send it to the web server to be processed by the XML library. Like I mentioned, when it will output and process it, it will put the content of the HSA hostname in this case into the result, and gives this back to us, to the attacker. So I think now we have touched the 4 topics very quickly. I think it's a good moment now to go to the GitHub page. Like you can see here, there's an outline of what you can do. I would say let's use the list that we see here. So first we do together the deserialization attack, then the server-side template injection, the course, and then as final the external entity injection. What you can do is you can install it locally, or you can go to the HTTP website you see over here. There's an instance available, and there you can also do the hands-on part on. Also, when you will click on one of the vulnerabilities, you will see a bit of the description, what it is, and what the objectives are.
Yeah, so basically, the GitHub gives a step-by-step guide on how to do your reconnaissance and how to effectively exploit the vulnerabilities. So if you get stuck, then you can refer to the course outline, and then you can effectively follow the steps, and then you know what to do and how the exploit works. And we'll help you with by doing so. Yep. Ja, wat is het?
Dan is het handig om die eerst te doen.
Ik zou ze laten vloeien. Kijk, want als we dus naar beneden gaan, dan wordt het allemaal precies uitgelegd hoe het werkt. Die payload die staat daar gewoon. Dus als ze vast komen te zitten, kunnen ze gewoon daarnaar refereren. So you can figure out yourself, but the all has book, and if you can't figure it out, you can just find the website. No, we really wanted to not do that approach because what I mean is from experience that you, so a little while ago I started to do practice with that, and basically then you come in and it's like, oh yeah, here's this Apache first vulnerability, and you already know how to get there and you know what to do, right? Yeah. But the most important step is how do we come to the conclusion that that type of vulnerability is actually there too. So it's also nice to know some steps for reconnaissance to actually get to the conclusion like, hey, here's this vulnerability. So that's why we let the modified business here there as well.
No. Do you guys have a hotspot or? I'm afraid that will be the only option then.
Once you join the Wi-Fi, there is a registration page, Surfside email ID, and he will approve it. JTAPP. Did you register beforehand? That's not working for all, it seems.
No, the login code was only active till 7 to log in and yeah, apparently. Look.
Yeah. That should be valid much longer. Okay, sorry. Yeah, just send me an email. So basically, what we're going to try to do is just to exploit all the stuff we just discussed. So what else is the set of left out? What I'm kind of missing is most of it. That's the conclusion that some part of the application is vulnerable for attack with the end, right? So then it's also very important to teach yourself how to do the proper reconnaissance and conclusion that part of the system is vulnerable for that type of attack, right? So basically what we did is the course outline. I gave some steps on how you could do your reconnaissance. Okay. For example, the first step you could take is what you also find in the outline is to run Bandit. So Bandit is a passive or static analysis tool, and that really already gives you a very good idea where all the different vulnerabilities are.
What do you point to? Sorry, I'm totally on you with this.
No, that's okay. So the idea is that you first git clone then the project locally, and then when you did the pip install bandit, you can use the -R to the location of the to the clone.
What to do, right? The most important thing is how do you know that there is custom scripting or custom test, for example? How do you get to the conclusion? And in the outline, I describe step by step, like, okay, if you try to do this, then you see this response from the application, and this response from the application is a very good indicator that this type of vulnerability is there.
Okay.
Yeah. That's the outline.
It's exactly like if you want
Is it working for you?
yeah.
Yeah? Okay.
Just to try one single code.
Exactly.
And if that test succeeds, you have SQL injection.
Exactly.
Similarly, to find others, there are some other tests that you need to perform to identify if that exists or not.
Exactly. So, in my opinion, that's the most interesting thing to know, right? The whole process to get to that point where you effectively identify the vulnerability. Because ultimately, if you do pen testing, red teaming, that's like 80% of your work, and it's actually doing the reconnaissance, mapping the application, see what type of technology stacks are used at what point, and then get to the conclusion you can effectively say, okay, with all this information I have right now, I know this function does deserialization. So since you already have the source, then you can effectively also use static analysis tools. And if you would run Bandit in the source code, you already get a whole lot of information. And also, for those who cannot run Bandit, all the information, the output from Bandit is also already provided in the course outline.
Yeah, I have them now on the screen.
Yeah, correct.
Like I just cloned it, so I think it's in course.
Yeah, so that is the whole idea.
Yeah, so are you using Python 2.6 or 3?
Together. Because the only way to learn this is to really get
No idea.
No worry.
the behavior of the application.
When you said point to the code, which file am I pointing it to? So I get the whole zip download.
Probably you can use to point then. if you're in the root folder of the.
Okay.
So bandit space minus error and then dot, I guess. Just dot.
Oh, it's just dot?
I think it will take the current directory.
The whole entire directory?
I think, yeah. Yeah, looks good.
Alright,
So probably Bandit will give you more hints, not only about this one, the deserialization issue. So you can see that it will find at least the pickle and modules vulnerability. So this one, B301. And it will also find another possible deserialization issue, B506.
so if you look at the screen, you can also effectively see the location where the vulnerable piece of software is located at, and also the vulnerable part of the function. So that already gives a whole lot of information of where to look at.
Yeah, so apparently in the project controllers in the about.py, there's a piece of code that this static analyzer tool says, hey, it looks like it's vulnerable for deserialization attack. And similar in the controller information.py. So
Yeah, well, the problem is if you have for static analysis tools, then you probably want to have a good one like source to state analysis. Those tools are mostly really, really expensive, so then you get to your HTTP check marks and all that stuff. Yeah. So most hospitals, those is really expensive, and you should look to also for example, OWASP dependency check. So basically, what OWASP dependency check does, it installs the application, or it installs the native install, or the new get install, or the install. And it just finds the whole dependency.
yeah, so you need to go to the root directory of the git clone you did.
Libraries, and it basically correlates the libraries it finds against
Okay, and now you can do bandit and on -r and then space dot, like the current directory.
find the library. The library has a requested scripting and whatnot. And then you already get more information about all the dependencies.
So it's now doing a static code analysis, and you will see here.
Thanks very much.
I think you need to scroll more up. Yes. So here you have all the findings from this tool. And here you can see that it will complain about pickle in the about.php, ph, but also information.py. And if you click on the application itself, you will find when you click on this one, you will go to that piece of code that is vulnerable for a deserialization attack. And also what you can see, there's a weird value here in the URL, right? So I would say try to see what the value, the real value is that string holds.
So can you tell me where can I go to find, like let's say if I'm doing deserialization?
Yeah.
Where should I go here?
So here we see that one is the about.ph, and a bit the other vulnerability it found is in information.py.
Okay.
So if you go to the target application, here we have information.
Okay. Yeah.
This one, yeah.
Okay.
And as you can see now here in the top, there's sort of encoded string. So now the challenge is to see what that is, and then see how we can attack it and. So what it here does, why it's vulnerable, because you have a YAML, it loads it directly without any checking, basically.
So basically, it's a hapless browser that does process scripting, SQL injections, and all that good stuff. Basically, checks the request and response from the application, returns everybody play around with this for a bit. And then after all, like I said, don't get discouraged if you don't get all the vulnerabilities, because yeah, these are really hard topics. And you know, I also have all the course outlined and the vulnerable targets to practice on, right? So, but if you take a look at the data, what does this look like?
So, who found already the locations of the deserialization vulnerabilities in the web app?
So now you inject your own object, and then from that you will find
Not yet.
sleep for 10 seconds, which is an indicator.
Okay, one of the vulnerable places is on the information page.
Yeah. So now your object gets deserialized by the YAML parser or by the YAML function. And now you see it takes effectively. Exactly. Oh yeah, of course.
Just getting it.
So from the bandits output, I could see, I found that this particular line, because it's being used, is the issue.
So
Right.
is it like
So after that, I was not able to understand what's the next step. I come here and check what's the,
Yeah, so
so I saw that it's on the about index.html page, it should be there on the website. Okay.
yeah, exactly. So
Okay.
so now you're on the about page, and indeed here you have the functionality to sync data between applications. Here we have an example of a data object that was synchronized from another application, and now you have input to send your own.
So here is the place where I would try the malicious.
Exactly, yeah. So this is one of the vulnerabilities of the deserialization. And information, this is the other one. Because this is using YAML, and this one is using pickle. Two different forms of deserialization attack.
Okay, so now I understood that on YAML, this page, when I come here, I click here, and I found this.
Yes.
Okay, but how do I understand that deserialization is being happening over on this place?
Exactly. So you don't know yet. First, you need to see what is going on here. And what is weird is this long string in the URL. So that is the next focus point on to see what exactly it is. Is it like an encoded string? Is it?
so this is
Okay, got it. Now I got it.
Yeah. And that will then, if you figure that out, you will see that there's a certain content in it, and then you probably know the next steps.
I was able to do that, the deserialization.
Ah, okay.
I mean, I did it. I'm helping her out now.
Ah, okay, perfect. Is it working?
Yeah. Yes. Oh, and then do we just go to this website or? That's right. This one? No. Can't even find it. What's up here?
Yeah, so here you can see that in the about and in the information.pa, that in there, in those methods, that there are two different forms of deserialization. And one of that is this one. If you click on this page, that's the information. And if you click on about, you have the /about. So on those two pages, you have two different type of deserialization vulnerabilities. And for this one, what is being done, this value here is being put into the YAML load method, and in there is the deserialization. But first you need to find out what that string is, like what type of value is it. Well, decode it then. Well,
Do we have to go to the website?
yes, because this is an online. You can also start it locally, or you do it online.
How do you start it locally?
So let me get the. So what you can do is this. If you have Docker, you do the Docker stuff. Otherwise, you do pip3 install -r requirements. And you need to do this in the target directory. So now you go to cd target. Yes, and in here you do pip3 install -r requirements.txt.
So is it just pip?
Yeah, so if you have Python 3, you do this. If you don't have Python 3, you can just do. Yes, then I would recommend to just go to the website. The stuff will be online, so you can also at home just install the Docker or install the Python 3. Well, this website we will, like the demo, that's online, we will kill it like tomorrow. But this, the project, the clone, and that will be here forever.
You might want to share this info on the WebEx, because people on WebEx can also.
I'm sharing the screen though, but. Ah, yeah, indeed. So it should go to this website that you see here, the IP address. Then they can do it online as well.
Yeah, but now you have to find out what is exploit. Because you want to inject an object that's being.
So I'm gonna give you guys a hint. So if you look at this page, over here, you have the information, and there's a string there. So if you go there, copy it, then we do base 46 decode. Decode. And now you see here, this base 64 string resulted into YAML, semicolon, this information is still in the construction, updates coming soon. And if you remember correctly, if you go here to the website, you see there's a piece of text there. So basically what this does, it takes this object here, reads the content from the YAML tag, and then reflects it here in the page. So
Yeah, so a Handson would be, you found that there's this pyaml.load. Simply Google for pyaml exploit and see what type of information you get from the search engine. Because that's where it all starts, right? So you run your tools and you do your reconnaissance. So then you find, yeah, this pyaml function is being used. And then you start doing your research. So what is pyaml? How does it work? How can I get my own object to get serialized by the pyaml library. So now we're going to effectively go on the hunt for exploit code. Yeah, so then now you can check in the source code. You can see here the location is OWASP area, target project controllers, monitoring. Right. That's where the vulnerability is. Or not really the vulnerability, because what it only detected is there's this US OS.p open. It knows it's going to do something with a system call. You cannot, or you can invoke this directly.
This will basically give you a chance to take commands in, but the thing is like where is this like how
This Surfside template injection.
okay.
Because, like I mentioned, with Surfside template injection, you can also invoke Python classes it does. So there's two things you can do. You can iterate through all the objects in itself, or you can iterate through all the objects that are used by the template engine. So you have these. So in the running software, it has a lot of classes, right? So the templating engine is just running software, which has a lot of classes in it, with methods. Some methods can be some methods can do system commands and whatnot. And if all the classes and objects you can iterate through really properly sandbox, call them through the template expression, and do arbitrary code execution.
Right.
But sometimes, because how the application and the function is built, you can also invoke classes from the application itself, other than invoking methods from the self object from the templating engine. So this is being set up in such a way that you can invoke this class through a templating expression. This is a really hard one to wrap your head around. And then you have to first start with the If you go to the application, then you can log in with Xss.
Yeah.
URL has XSE.
That's a good question.
The slash validate is the validator.
Yes, indeed. I think you need to log in first.
Oh, okay.
No. This looks like somebody wrote it. Can you go back to that? Or something else? Can you use the information?
Let me try also here.
It's the validator directly.
Yeah.
Okay, thanks.
Now I think I have to reboot the app. Seems like some hacker here broke the app. Huh? No, that's pretty nice. If only they could tell me how they did it. That's the most interesting part. Wait, let me reboot the app real quick. I left the phone. I have to reboot. Good thing it's a Docker container, so I can kill it and. So, small suggestion from my part, since everybody's using the thing on Google Cloud, I provided the most interesting findings you can get already in a report, a work report. So, please stop scanning the app for Burp. Because I think Burp will probably try to backdoor injections and Thompson stuff. So it's now down for a few seconds. And we're back up again. Okay, instantly find out the traffic. Ja, dat is goed. Moet je login nog eruit doen. Zelfs gaan rebooten. Even naar boven scrollen. Even naar hotfix nu. Je hebt nog hotlopen? Ga ik even staan voor hotfix.
So I guess it works. So then, do we try to get RCE? Because this is like speaking for 10 seconds, right?
Yes, exactly. Yeah. And normally, of course, when you do the sleep, because you cannot really see the output, so that's why you use the sleep so you see it. And yeah, normally the next step would be a remote reverse TCP shell back, so you can execute commands. So that is one of the first, the information. Then you also have the pickle load. That one is in about the system state. This one. And what you need to do here is create a valid serialized object that you then can synchronize this app with the object. Also, if you just type some stuff here, just to see like what would happen, you see that the synchronization didn't work. Maybe some weird. So you need to find out, okay, what exactly can you do? The only thing you know, it's a full object that you can put in here. And like we mentioned, that's dangerous. So the idea is now that you craft an object that you then can use to get also code execution.
Yeah?
I'm still getting the same error.
Yeah, I'm doing a hotfix.
Okay.
Sorry.
Did you try this attack already, this serialization?
I'm trying this one, and then I'll go for that. I'm trying this one. Starting a process with a shell.
Mm-hmm. The system call.
Yeah. But I think I'll try a different one because it'll take time to fix it.
Yes.
I think I'll need another 30 seconds.
Mm-hmm.
So for the XSC, I use this input.
Mm-hmm.
Okay. Basically URL but I don't see that payload getting executed.
Mm-hmm. I would just paste it.
As it is?
Yeah,
Oh, on the browser?
yeah. Then it's easier.
Okay.
Are you redeploying it or?
Yeah, it works.
Okay.
Freaking love Docker.
Very close.
Okay, let me try now.
So this is the exploit code you have to run to get the serialized
Let me
object.
try.
So if you let me just sit right next to you. So basically what happens here is
Let me also check it.
so if you would look at the source code, you can see it expects a hex encoded string with serialized object in it. So basically what this class does is it does exactly that. So it returns our system sleep. So this is our arbitrary system command, right? And you can see bin ask. So it's hexlified. So it's going to make a hex string out of whatever people.com stuff. And that is run bin sh. So that is this class. So we now make a serialization of this class. So we serialize this class, but we print it as a hex encoded string. Because then, if we have this hex encoded string, we can feed that to the application. It will dehex it, so to speak, and then it deserializes the object, and then you can do arbitrary system commands. So you can. Have you looked at the event output? No. So if you were to read the outline, you can see how this works, why this works, and then study the code some bit more to see. See, now you can see it takes a while for the server to respond. So then you effectively know that your exploit works. So you will not, in all cases, be able to effectively tell right away if your exploit works, right? Because most of the times the output simply gets into your console. But then if you let the application sleep for some seconds, you can effectively tell by the response time from the server that your exploit worked. So that's a really good thing to use, while trying to discover your exploits. And then from here, now you have your code execution. You can start, for example, setting up a netcat listener on your own device and to reverse TCP shell ownership, do your privilege estimation, and then you own the blocks.
Sorry, thanks, we should.
Sorry?
Thanks for that.
Yeah, no problem. Yeah.
So, this error. Yep. So you just print this and then.
No, so for the XML payload, you don't do it with a standard here.
Don't know why it works.
So you try to download the example, put it in here, right?
I did that. Now I'm using the exploit tool sample.
Yeah.
Instead the same thing here.
Yeah, now if you would run it,
Okay, got it. All right.
this will probably work.
You want the second one? You do the second one.
Maybe.
Oh, we did this.
Can I check the echo? Because I tested this in the morning locally.
All right, check it with this SSTI.
Well, I'm kind of wondering if my Docker environment has a delete.
Oh, sorry.
Okay.
So maybe this is a file that is non-existent on the file system at this point. Because my local machine, when I run it as Python, version, if it exists, of the then
It's issue due to meet.
it needs a lot of work. It's not really, and I saw how to react. Ja, maar dit is op jouw machine, maar ik weet niet of dat in Docker zit. Let me create a file, Docker image, or from the file system. Then I have to do Docker attack to see what files are in the Docker image. Because maybe EDC/password is not existent there. Because I built the image from Python 3, so maybe it's not there, but I can check. Because then obviously EDC/password would have worked.
Yep.
So maybe that server that's trying to run instead of EDC/password, then they try to fetch requirements. Without the EDC. Because if you look at the root of the application, this would be there. I can also check if there's. But there is a EDC/password. It's very strange.
How about is it working on the local Docker instance?
If it works on a local Docker instance, I don't know, but it works when you run it with Python. Why wouldn't this work with Docker? That doesn't make sense to me.
Xss.
is een spatie voor, die moet sowieso weg. Helemaal bovenin. Ja, lokaal doet het wel.
Yeah. See, locally it works.
Yeah, but now I'm thinking if you might have the same issue. Yeah, locally as well. If you run it in Docker. Yeah, well, I just done it with Python. I just done it here. I think we also
So maybe Ricardo, it's a good idea that you show the 4 vulnerabilities so everybody has seen them. And then we move to the next,
Yeah, cool.
because we also want to deliver still the presentation about the security knowledge framework, the software development lifecycle. We start a bit later, so yeah, exactly. To show the presentation as well.
Now, first want to show the exploits or the presentation?
I think let's finish the presentation.
Yeah? Okay, cool. Because all the steps for the exploits you can actually find in the write-up.
Let's do the presentation.
Yeah?
Yeah, and the advice is to, when you want to do those, just run the application locally, so then all the exploits work very well. So the other part that we wanted to show was the presentation about the secure software development lifecycle. As we've seen, we have some very advanced vulnerabilities, but we're still also fighting a lot of known vulnerabilities like cross-site scripting, SQL injection and stuff. But of course, we have a bit of a challenge, especially when you release a couple of times a day. Like, how do you incorporate security into your whole development lifecycle? Well, there are a couple of things you need to consider. For example, there's good security requirements. So think about the ASVS. Who knows ASVS? Awesome. So that's another project from OWASP. It's also a flagship project. It stands for the Application Security Verification Standard. You also have the NIST version of that, the security requirements. So everything really starts with having the right set of security requirements when you build your application. Then, of course, you have test automation, so code quality. Think about your dead-end code or duplication of code, complexity of code, no standardized way of how to do name conventions and stuff like that. That's basically code quality, and we can tackle that with test automation. Then we have a good part of the software development lifecycle, and that's the security test automation. So there we have 2 flavors. We have the static tooling and the dynamic ones. Bandit, for example, that's a great tool. As you saw, that's like a static version. It looks like dangerous methods and functions, and to see if user inputs goes into it. And the dynamic tooling is testing the tool from a dynamic point of view, so it's actually running and in a different state. Not last but not least is the manual verification, so doing the secure code audit, like manual reviewing, peer reviews, secure code reviews, and of course penetration testing. But yeah, the whole thing, and that is what I already mentioned a bit, like what is the problem? What is the challenge of doing really SEC DevOps work? I mean, we have automation, it's very nice, but when you release a couple of times a day, at least, what type of issues will you face? Do you encounter certain issues when you do SEC DevOps? So truly DevOps, 20 times releasing a day, and also incorporating security into it. Who of you guys work with a software development lifecycle, like a pipeline already? Who has it or use it? So, and in there, what are mostly the pain points?
Getting the penetration testing done on the time.
Mm-hmm.
So relying more on the testing to find the security issues, not doing the validation before testing,
Mm-hmm.
like source code resolution.
Mm-hmm. Okay. And that is even like a process and human, like a resource issue maybe also, right?
Yeah.
So that is one of the issues you identified, but there are way more. Because, you know, most of the tooling, they take way too long to give feedback to the developer. If you have a big project and you do a code review on it, like 45 check marks, whatnot, it can take sometimes like 4, 5, 6 hours. If you have a really big project, couple of lines, like million lines of code, I've seen them run for like 22 hours. So if you want to release like 20 times a day, the feedback loop is way too long, right? But also why we really want to push DevSecOps is also, you know, powering by the teams, doing truly security by design. Yeah, and you know the way we want to present it and show you guys like the benefits from doing certain things is also quite interesting. So, you know, when we talk about the static part, we already mentioned a bit. So you have AppScan, Fortify, Bandit, the dependency checker, all great tools that you can incorporate. Some of them will run really long, and yeah, nice to have, but there are some limitations. Then we have the DOS dynamic. So OWASP, for example, is a great one. FSpider, Burp. Well, we all know the tools probably that are mentioned here. Same interesting thing with this static code scanning, that some of the tools can really run for hours, and yeah, mostly only find low-hanging fruit. But like I said, you just use what you think is right for you. Some of the tools have better support for different types of languages, so that's something you need to assess on your own. Also, when we look at the Icd tooling, we have some favorites over here. We, for SKF, for example, use Travis. At ING, where I work, we use Jenkins and GitLab. Yeah, great tools to help you set up a nice CI/CD pipeline. Here, for example, we have drawn it a bit out. So you have your repository. For every pull request that's being done, you spin up Jenkins, weaponize him. Basically, it will kick off different Docker containers. For every Docker container, you have your security tool, like a dynamic or a static version. They run, they push the results back. The findings go into a tool called Defect Dojo. It's also an OWASP project. It's basically doing vulnerability management system. And we will come up to a point that's why that is really important. Yes, sir?
Defect Dojo like Redfix. Like,
Yeah, but then free, they get better support. Well, in America, I think you get good support for Redfix because they really want. I think America is their target audience. But if you're in Europe and you want to have Redfix and you're like, hey guys, I'm ready to pay 40K for a license, you bet your ass it will take like 3-4 weeks to even respond to that. Like, oh, you don't want to have my money? Okay, cool. So that's why we really started to go for Defect Dojo. First, it's an OWASP project. There's always also a very big community and whatnot. And secondly, yeah, the response time I got from Defect Dojo, even as being an open source project, was way better than Redfix. But it can, like I said, it can kind of differ because I have the idea the primary market for Redfix is mostly US and not really Europe. So What's also really important to notice here is that this is a really agnostic approach for setting up your whole security test automation. Because normally, like you see at the last slide, like you have Travis, you have Jenkins, you have GitLab, you have Go, whatever. There's like millions, well not millions, but there's a lot of CI/CD tooling out there, right? So if you want to incorporate your CI/CD tools in the pipeline, then you're probably kind of dependent on what type of plugins your CI/CD tools provide. So by containerizing all your favorite security tools, you have this agnostic approach where you can simply deploy your containers from all different CI/CD environments. So as being a consultant or the DevOps engineer in your company, that's really awesome because everybody's self-steering and all the groups can determine what type of technology stacks they want to use and what type of deployment tooling they want to use, right? So then it's really nice for you to not have to reinvent the wheel over and over and over and over again for all the different CI tools out there. You just containerize your favorite security tools, boom, and then incorporate them like that, in your favorite or in your developer CI/CD environment.
Exactly, yeah, and if they may change in the future, no worries. All your tooling is in the Docker containers, the security tools. You just kick them off in the new CI/CD environment, and you're good to go.
Exactly. I've seen a lot of work going in Bitlock where I really configured on the tool itself, and then they had Jenkins, and at one point it's like, oh, we're going to use GitLab, right? Okay, there goes my work. Straight into the Bitlock. Bye bye. So that's why it's really good to take that approach. Ultimately, after you containerize all your favorite security tools, you will come to the point where some of your developers also use cloud services. So you have ESDS, so there you have your View Foundation server in the cloud, or you have Travis, or you have your GitLab in the cloud, or whatever. And then you have a limited amount of agents or runners or whatever. And as my brother already mentioned, if you, for example, run OWASP or Fortify or whatever, that can take like 6 to 22 hours to run, right? So if you have a limited amount of runners or agents, you don't want to occupy them with a scan that runs like 6 hours, because can you imagine if you have 6 runners and 10 developers did a commit to the repository and that code starts to scan? Nobody can build or deploy any of their applications anymore, right? Because you're occupying those builders. So what you then want to do is you basically just want to let your CI or your favorite CI/CD tool schedule a job in Kubernetes and deploy the pod there with your favorite security tool in it, and then it runs for like half a minute, and then the agent is no longer occupied. And then if 10 or 20 or 100 people, deploy a SAP container, it doesn't matter anymore because your Kubernetes cluster is very scalable, right? So that's the whole idea of this setup.
But to come on one of the other pain points that we want to point out in the software development lifecycle, that is something called false positives. So I guess you guys have heard of it, right? False positive. So the scanner, the tool said that it's a valid finding, and after a lot of research, you find out, oh, it was a false alarm. It isn't actually a vulnerability. So that's a really big pain point. And just to give some metrics, we have another OWASP project, the benchmark project, and they plot out how well certain type of tools are. So how many percentage of the vulnerabilities are true positive or false positive. And of course, the higher the rate in false positive, the more work you need to do, the manual labor to review them all every time there's new findings. And of course, like you see here, the ideal vulnerability detection is up in this corner. So almost no false positive and only true positives. And if you see like here, the tool reports everything vulnerable and it's all false positives. What they did is they took some tooling and they plotted it out. And unfortunately, the results from it is quite interesting. Most of them are around here. So around 40% of them are false positives, and 30% of them are only like true positives. So the added value that those tools deliver is very low. They find like low-hanging fruit, easy stuff. They will pick it up, but most of all the other stuff they won't find it. And that also brings me to the next question. So let's say you have SaaS tooling, you have even multiple SaaS tools, you have multiple dynamic tool. How much percentage of all the vulnerabilities do you think you can find when you use those type of tooling combined? So who thinks you will find like 90% of the vulnerabilities with those two type of approaches? So doing a secure code scan with different tooling and doing dynamic scanning with different tooling. Who would say like, well, I think you can at least find 90% of the vulnerabilities? Or lower or more? Who's lower? Okay, how much lower?
I think about 70 to 75%. After that, your logic works.
Okay, and who thinks it's less than that even? How much do you offer?
So the business logic vulnerabilities and IDO kind of vulnerabilities, it's difficult to find through the tools. It's some manual intervention is required.
To be honest, business logic is not only hard, it's impossible. I didn't see any tool in the market that can test for business logic. And business logic flaws are good for 50% of all the vulnerabilities. So think about it, 50% will already drop from the coverage. So the answer is at least below 50% of coverage. If you would use multiple SaaS and DOS tooling.
That's really low.
Well, it goes even lower, to be honest. Unfortunately, the average is around 15% of all the vulnerabilities you can find using SaaS and DOS tooling and also multiple versions parallel running. So like Fortify, OWASP dependency checker, check marks. Even if you have like 3 projects and a couple of DOS, it's still around 15-20% of total amount of vulnerabilities you can find this way. And that is because, yeah.
How do you know what the total number is? Say that's only 15% found.
So, for example, if you go back to this project, here you have a demo setup application where like known vulnerabilities in it, and the tools can benchmark against it. So can prove like, okay, look, this is how many I can find. Yeah, and based on those figures, you come to that conclusion. But nevertheless, like I say, 50% of business logic vulnerabilities fall already out of the scope of those tooling. And the thing is also, you remember when we had it about this JavaScript and data double point, as those type of injections. It's edge case. It's really hard for scanners to understand that there you need to have a different injection.
OWASP finds JavaScript column number, but Bird does not find it.
Okay, yeah.
Against the target tool. Just good to know. But as you can see here, so even though the coverage is very low, or not as much as we hoped it to be, you have to keep in mind that the biggest threat on the internet is, of course, automated attacks. So as soon as you deploy something on the internet, you bet your ass it's going to be scanned any second from there. Because effectively, how much time does it take to scan your entire IP range to one port?
Well, if you only have like one data center, like uplink connection, only use one, then it's like 35 minutes.
So you can imagine. So as soon as the security researcher finds a vulnerability, it makes a report and submits a reporting meter. And they have this big list of all these. So as soon as you report it, it gets a CVE ID, and from that point, that CVE ID is correlated to that vulnerability. So you can imagine that somebody finds a vulnerability and reports this from their own. For example, there's a vulnerability somewhere, they do a patch, people reverse engineer the patch to find out what the actual vulnerability was in the version before that, and then they weaponize that vulnerability and then scan the entire IP range in like half an hour, like my brother said, to find all these web instances and services which are actually vulnerable for this type of vulnerability. So kind of depending on what type of business you have, I mean, if you have this business where you do all good stuff and you bring people flowers and whatnot, then you probably will not be affected. But if you are this business who slaps people with flowers, then probably there will be some activists trying to hack you, right? So it's also all risk-based. So if you have high profile, then probably hackers themselves will also try to attack you. But in most cases, automated attacks are the biggest threat on the internet for your application, for your services, and whatnot. So even though security test automation doesn't really have high coverage against somebody actually personally trying to attack your web application or your services, you do protect yourself against automated attacks. And that's also really valuable in that sense. So for people who really, really got an eye out for your organization and really see like, hey, if I put in this effort, then it's really tickety boo, it's really nice because this pays my efforts, but it does help you for all the automated attacks from the evil internet. So that's good to keep in mind.
Here we have the results, by the way, of some of the tooling. So here we have a list of numbers, letters, KLM, NLP. Those are all commercial type of tooling. And then we have the non-commercial. So as you can see, some of the non-commercial scores even as well or better as the paid versions, right, of paid security tooling. And some are even in the right top corner, like random guess and really worse on the amount of false positives compared to true rating. And, you know, in bird culture, we call that a big move. Because you know how many false positives, you're only busy with it, doing research and going a lot of time into those research. Because you know you don't want to deploy something or put something in production that might be a security issue. You need to investigate. What is really also important is having like this vulnerability management system where you can do and do the triage between all the research you do and then come to the realization this is a false positive. Then mark it in the tool, the vulnerability management system, this was a false positive. So when you do a next time a scan of the application, that false positive is not popping up anymore. So you have to do the review once. After that old or like that false positive is not going anymore. We call it that like a delta reporting and the suppression of false positive findings. Defect Dojo is, like my brother said, an OWASP project. This is how it looks like. So it looks a bit like the workshop thing. So here we have, for example, the dependency check. That is a security tool that looks like to your libraries and what versions you're using. And then you can see, hey, there are known vulnerabilities for it. You need to patch it to a later version. And here we can also see that you can say that you verified them. You can mark them as a false positive or not. So that means they will pop up again next time or not, depending if you flag it as a false positive. And of course, if you click the vulnerability, the CVE, you get more information, what was actually the problem, what versions, and what action you should do. So yeah, that's really useful to have. It's a very important component in your software development lifecycle. Of course, there are other problems that we have, the secrets that you're using, especially in the world of APIs and certificate and virtual authentication and all that stuff. You need to also do certificate management and keeping your secrets in a safe manner. There's a project called Vault for it. And like I say, what we're trying to tackle with Vault is everywhere plain text secrets or in configuration files, source code in your control system, version control system. So there you want to replace all those secrets basically with placeholders or an API call to the Vault where you can get that information. Because to be honest, it's also a part where organizations really forget, to clean this up or have a good approach for it. Because it's so fairly easy to use these methods to gain access and get a foothold into the application or the servers.
Yeah, well, the best thing I ever found during the time test was this API key to the Jenkins server.
Yes.
That was a very good find for me. Not for the company, but for me. For API keys, for registries, for Docker containers and all that stuff, and artifactories, and that's where the fun starts for most pen testers.
But the good thing is, Vault can help you. It's an open source project from HashiCorp, and it's really proper, thought of, very robust, very secure. So you can store there the dynamic secrets. You have key rotation. The tokens are unique. You can revoke them. So all the things that you normally encounter need to solve yourself is in Vault. Important, all the information encrypted in REST, when you store it in a data set, or when you're requesting them using strong TLS and stuff like that. We talked a bit about the software development lifecycle. There are some pain points. So you have some coverage with SAS tooling and DOS tooling. But again, we told you guys, if you want to release like an agile way, like DevSecOps way, you still have, limited velocity. You cannot release 20 times a day because tooling takes a long time to run. So what would be really effective? What is the next thing, the other thing that we need to do? What do you guys think?
Call the meeting.
Sorry?
Call the meeting. Everyone else does.
Yeah. Yes, true. And what would you do when everybody's there and
Fear uncertainty and down.
we need to do something that's super effective. And something that is super effective is setting up the right security requirements. Because, a lot of developers, don't want to build insecure code. I mean, you have just a limited part of security knowledge. You try to do your best to implement and build secure application. And you do it with the security awareness that you have. So probably after today, you guys know if you build something with an XML parser, you will think like, hey, wait, those guys from the Netherlands, they told me about external entity injection. I need to do something about it. Otherwise, I have a big problem. Or I'm going to serialize that object, and hey, the user can technically also submit this to my application. Maybe I shouldn't do that, So it's all about security awareness, and setting up and having the right security requirements already, is a game changer. So we have the ASVS, you also have the MASVS, and those are those security requirements. Based on the level, the intensity, is the very critical application or it's a simple football match app, based on that you have different levels that you apply. The MASVS has different levels, same as the ASVS. So level 2 in this case would be with the resilience checklist would be for a banking app. Same if you build a critical application or an API, you use the ASVS level 3. And how does it look like? Well, you have a checklist that basically says what you need to verify. There you have the requirements, what you need to do, and also the test cases for penetration testers, how to verify it. So it's a really cool project. I must say it's a lot of information. Also the ASVS, like the ASVS level 3 is around 170 security controls you should implement when building a very critical application. So like banking applications or security applications. We know that it's very hard for developers, like where to get the right information from, what type of security controls, what those security controls also mean. So there is the project that we also created, the Security Knowledge Framework. It's an open source OWASP project, a flagship program, and it's really a guide for secure programming. So it's an application that will do security awareness for you up front before you basically start programming. And the idea is that we give the right set of security controls based on the changes or the type of functionality you're building into your application. And everything is open source and, transparent for everybody to see or fork or adjust or contribute. So here we have an example of the application of the security knowledge framework. So this is the landing page. If you would start it or go online, then you will see this. The first, most important thing is that we have the checklist. So all the security requirements are checklists. You can view them online. You have the knowledge base section. So basically there we have different knowledge base items about command injection, for example. There you have a description of what the command injection is, what the attacker can do with it. But more important, also the solution for you as a developer, how to mitigate this attack and this vulnerability. We also have code examples in PHP, Python, .NET, Java, and all that, like the most 45 used functionalities in applications like file upload, setting headers, input validation, you name it. Those we all have code examples with heavily documentation. Also to give you, also on implementation level guidance, like, okay, why would you approach this way and the reasons why, and really make your application defensible, on its own by doing very strict input handling, type checking, length checking, whitelist approach. Here we have an example of the checklist. So it's structured by a category, and then we have the security controls that belongs to that category. And again, if you don't implement one of those security controls, then there is basically an attack vector. And in this one, all app components are identified and known to be needed. The attack factor there is if you have components that's not needed, you just have a bigger risk that an attacker can abuse functionality that you don't even use or need and use that as a stepping stone. And that could be prevented by just removing it from the project. Also important, you can create a new project. So you can use the security knowledge framework as a process and into your process of developing. So in here you can create a project. You have the pre-development settings. And what we try to do here is, normally the ASVS has 170 security controls. And most of those 170 controls are not applicable for you. And to go through 170 security controls every time you want to do this quick release, work agile, and whatnot, it's not good. So we created an expert system. Pre-development settings, those are like, okay, do you have a single sign-on solution? If you do have it, from those 170 security controls, already then 30 are checked. Like, okay, we don't need to verify or check that because that's being outsourced to this, like a general component you have inside the company, like a single sign-on. Some of the companies, they have a sort of blueprint for deploying a new server with a new application. They use a golden image, they do use already hardening, and all those things. So again, a lot of the items from design architecture can be removed from the 170 controls. So we want from the 170 controls really go to only the controls that you really need. And by using a couple of questions and answering them, we can narrow it down, knowing and giving exactly to the developer what controls are needed. So based on a couple of questions, we go back from 170 security controls to 54. So that's already a huge benefit. And why still 54? Because a lot of the things you need to set up the first time. Yeah, like the design architecture, you do that once, it stands as a house, you done a check, okay. For the next sprint, you have way less type of security controls. And based on what you changed, and based on the answers he gave in the security knowledge framework, it will select like 7 items or 8 items. And the idea is that you do this expert system, you fill it in, you answer the questions, you get 1 or 8 items back, and based on that, you have then the overview. For example, verify that all application components are identified and known to be needed. So this is one of the items that's recurring all the time. You have the awareness like, oh, I'm going to release this, I want to build this functionality in this sprint. I need to take this security control into consideration and make sure that I do it and mitigate it. So before you start writing code, you already are getting awareness on the things, on the security requirements that you need to implement for that specific sprint or change that you want to do in your application. And the whole idea of the security knowledge framework is to making those threats, really visible up front. There's no place to hide. There's no blind spots. It's really being aware up front of what is awaiting. And it's really for you guys, to also, participate in it, like taking the right choice and also the responsibility, to incorporate this. I mean, it's a bit of work. You need to really learn a bit the new design patterns about secure programming and the defensible approach. But if you really want to build good quality applications, security is also part of that. And the Matrix, Neo, is always trying to dodge bullets, but he doesn't have to dodge bullets. He can simply stop the bullets, and that's the whole idea, of this approach, to get the security awareness, having this guidance and tool available, to become the Neo that simply can stop the bullets instead of having to dodge them. And that's also what we try to really achieve here, is to make from every developer like a security champion, to make from every developer a Neo, basically. Here we have the security champion. Sorry? Adobe, yes.
Why Adobe?
Because I like the belts.
Do you like Flash as well?
To heck. Yes. No, funny thing is, my brother and I were really martial arts fans. So I did a karate, judo, jiu-jitsu, kickboxing. So I like belts.
So, we create a lot of products with Adobe, and Adobe is the most difficult company to get some of the security requirements accomplished. Yeah. So we use some of their products, and we find it. So some of the APIs, we tell them these are insecure. It's very difficult for them to get that corrected.
Yeah, so maybe this is their whole strategy.
Quick question. For the security knowledge framework questionnaire that you were talking about earlier, so you can eliminate certain requirements based on having an in-house single sign-on solution or an authentication or authorization solution. What happens when it's the team that actually maintains that single sign-on solution or authentication or authorization service?
Exactly. So that's a good question. Normally what we do is, yes, we use a general solution for it, so it's a team or we use a product. But of course you need to have done the ASVS on that specific thing. And if that's vetted like, okay, they met the security controls, then it's indeed in your next project that uses component, the single sign-on, that you can say, okay, no, I don't want to, because we have it and we have it tested already.
Okay, so basically you would just run through as if you didn't have one with.
Yes, we exclude it then. Yes, yeah.
The thing is, of course, if they start developing on that single sign-on, because we have 2 different types of questionnaires. The first questionnaire goes through all the architectural stuff, the high-level overview, and then we also have some questionnaires. So then, whenever they're going to make changes to the single sign-on, they will also go through that whole workflow. And basically, one of the questions for the sprint questionnaire is, are you going to implement change or change authentication? Right. Then they will check that to yes, then you get the security requirements for authentication, authorization, and the hardening for single sign-on and that stuff.
Okay. they will go through that whole flow, and they will be presented with security requirements that correlate to building single sign-on identity providers and all that stuff.
Okay. Yeah, because I've seen environments where someone had an in-house solution and it's handled by another team, but the other team makes changes, and obviously when you're dealing with that other team, they just have their own requirements, you know, for what they're doing.
Well, in this case, if the team wants them to make changes, they will also have to go through this flow.
Okay.
And then ultimately, they will be presented with correlating security requirements.
Great. Thanks.
Yeah, so, you know, to come back on, you know, you as a developer being Neo, being awesome, don't having to dodge bullets, we make the jump to the security champions, because that's basically what we see Neo, you know, like this awesome champion. Maybe indeed that Adobe says, you know what, we don't do security requirements, we only have this system. Because, for example, what they do, that black and brown, they can only work on very critical components, like authentication, authorization, like very critical stuff. And the other guys, like green and white, they need to be peer reviewed. They need to jump through every hoop, basically, that there is, because they are not that experienced yet and don't have that security awareness. And there's also incentives. So, for example, the black belts, they can release more often because they are aware. They have like 1,000 hours of security, like trainings like these and other courses that they did. And also using really truly the security champion, like, you know, somebody with knowledge that knows the security requirements, is security aware. That is truly, you know, the real solution to SecDevOps, because SaaS and DOS is truly only a sort of very thin safety net. It will catch some of the vulnerabilities, still good to have, but it's not good to rely on it. Where I would rely on is the developer and empowering the developer with the right security knowledge and the security awareness. Because in the end, there will be less pen test findings then, and also very fast iterations are possible. So really, you know, what we want to see, that you guys become the Neo and prepare for the truly battle, because you are really the only true solution to fix security and do security properly and by design. Yes, sir?
The security knowledge framework is potentially going to be extended, or does it currently support infrastructure as code?
No. That's a good question, because everything is going to be code. The same like indeed with the software-defined networks, cloud, and all that. But yeah, I mean, what is becoming there more interesting is the old configuration and the sprawl of secrets, because you're going to make API calls to other servers that will build your infrastructure. So, like my brother said, if you can get to an API key that can access certain services because you left it somewhere in the source code of an app or whatnot, I think those are nowadays the more risk points, you know, that people don't even control that and have a good solution for that. So our way is then implement Vault, make sure all those secrets and tokens are stored in Vault, and you can request them from the Vault. The separation of the build environment. Think about, I don't know, Jenkins, where you have multiple projects on a Jenkins server. But for example, in project A, you run a script that goes one directory deeper, and then go to project B and read there the secret file. In Jenkins, a couple of versions ago, it was possible. So if you had somebody else on your Jenkins, because that happens a lot, you share a Jenkins environment, you could still, from other projects where you technically had no access to, could still steal information or modify it, or But to come back on your question, in SKF there's nothing yet for like really infrastructure as code on how to do that.
We'll show you a demo of the new security knowledge framework, which we're currently building on, which gives you all the freedom to introduce your own checklist for infrastructure as code for all the things that you think that are important, and then create your own knowledge base items and all that stuff. So that's rather really interesting, exactly, because everything, infrastructure is code, and basically what it all boils down to is for configuration, it doesn't really change. So even though your infrastructure is code, as soon as it's deployed, the same rules and the same attack vector applies for your normal server, right? So if you want to have an overview of all the different requirements you would normally also make for hardening your own server in a normal environment, for example, your VM or whatnot. So that's really rather interesting to have. So we can definitely start working on it. And the new security knowledge framework also allows you to do that in an easy way. So it can also be used for PCI DSS, it can also be used for, I don't know, is GDPR a thing here also? Ish.
Yeah, it's the similar version, only different.
Okay, check. So then you can also use it for privacy checklists and whatnot. And also, of course, for infrastructure. But we'll show you how it works today.
So let's do a quick demo of the security knowledge framework. As you can see, we have a version running online, so when we do new changes to it or whatnot, then we can see it also in a running environment. Like I said, you can visit it on demo.securityknowledgeframework.org. The username is admin, the password is yeah.
If you go to secure.by.site, you come to the landing page of the framework, and then if you go to demo, you also see the username password on there.
So, like I mentioned before, this is the landing page. And as you can see, if I go to checklist, for example, we have a couple of checklists in here. The ASVS, the MASVS. So here we have the ASVS level 3. You can also click on the security controls, the items, and then you get a knowledge base item that is explaining more in depth what we want to achieve with this security control. The colors is for what type of level, so blue is for only very critical applications, yellow is for all, and green is for level 2. Yeah, like I said, it's very much excessive list. It's like 170 controls. And that's exactly the reason why we built this expert system in SKF to narrow it down as much as possible so you only get the controls that you really need. So it's a bit like a filtering for you based on your questions, your security requirements. Here we have an example of the knowledge base item, so you can click on it. What is XSS? So explain what an attacker can do. And here's a solution part for you on how to approach it and to mitigate it. Like I mentioned, we have code examples. So here we have a list of most common code examples or implementations. So here we have in PHP a code example to create cross-site request forgery tokens from scratch, and making sure that they're randomized and nicely, and they have at least 128 bits of entropy, so they cannot be guessed or stuff like that. And like I said, we have for .NET code examples. So here we have a .NET piece of code, how to implement, for example, open forwards and open redirects, because also that's a vulnerability. If you don't do it correctly, you can create phishing sites and stuff like that. Yeah, so again, the code examples are really to show people also on implementation and code level on how to approach certain type of secure programming. And last but not least, that is that I showed you before, to use SKF and getting the right security requirements. You can use the process. So here you can start your project, fill in the questions. So yes, yes. The sprint you're going to work on, and like I said, if you do it for the first time for your project, you will get a bit more security controls. But if you start a new sprint, you know, you will only get like a very small subset of the controls. So now it's correlating all the items. As you can see, it's selected now 32 items, 32 security controls that I need to implement. And like the gentleman said, currently we have only the ASVS in here to use it in the process. But nowadays we are also busy for like already a couple of months to build a very major new release of SKF, where we can also have you creating in SKF your own checklist, your own security controls, correlate them to knowledge base items, and also have the logic to say and build this flow yourself. So, for example, if you want to have one for infrastructure checklist, in the beta we are currently building, you can easily add it in the SKF, manage the checklist, think the questions you want to ask, and then to match which security control they need, or maybe they need to have certain security controls always included, like check your source code for default password or secrets or stuff like that. So we are building out a version that, that you can really define your own whole checklist. We had a small video of it, so we also want to show you guys what is upcoming. Hopefully in a month we can release it. Yep. But you know, a lot of people are waiting for the dynamic version of the checklist and the creation.
Is the dynamic version, so I pride myself on being lazy.
Mm-hmm.
In order to help facilitate that, I need export.
Yes.
Because then I can use other people's brain power and then import those that checklist. Or I can do it once and then serve a number of clients.
Yes.
Is the new functionality going to provide for export and import capabilities?
Well, currently we only have the expert of findings. So for say, because I didn't show it, but you know, the idea is that you verify those security controls. So now we have a list of controls. You can say, you know, the developer, okay, I did this because we use ABC, or developer for this security control says, I accept the risk, you know, I accept the risk. So he logs the audit, why he thinks it is, and that's it. And then the idea is that even the security key team can use this now, this project and these results, and verify the comment from the developer and saying, oh, the developer closed it because of this reason, checks it and says like, okay, I agree with him, or say, no, this is failed. He needs to redo it. It's not good. Then we have over here the failed items now. So there's one item that is failed, and this one he can export. And this finding can then be exported to a CSV file that, for example, can be imported in the defect dojo to track all your vulnerabilities. So that is the export that's in there. But I think with the new functionality we're building, you don't need the import-export, because the creating of the checklist dynamically, it can all be done by the GUI, and yes, you have to do it once to set up the security controls for your specific customer or project. Like infrastructure as code, for example. But you will have all the GUIs and the pages to do it. Because what we will deliver is, again, a checklist for ASVS, MASVS, PCI DSS. We will correlate it so you have a nice basis to start. But you can just say, you know what, I like your ASVS, but I don't like this item, this item, this item. You can just remove them, already shrink it down yourself, add items to it, or maybe even start a whole new checklist, but all using the GUI to click, fill in, and you can correlate stuff. But maybe let's have a look at the video. Maybe look at it. Maybe that also answers your questions a bit more, I guess.
Ja, ik zal hem starten. Dat is wel handig als ik er misschien bij zit. Kan ik ook starten en stoppen. Ah, maar ja. Ik ga wel even daar zitten, denk ik. Zal ik even daar zitten? So, like my brother already mentioned, so in the new release, you can really, customize everything. So everything's really modular now. So instead of working only for ASVS and MASVS, you can really import everything you want. So let's take a quick look. As you can see here, where you first had only a few checklists, you can also manage your checklists, add new checklists. You can add checklist items, and you can correlate new questions, and you can correlate and create your own sprint questionnaire. So here's an example of a checklist that's being made. You can see all the different knowledge base items and whatnot, questions for the sprint that's already being correlated. Here you can create your own new checklist item. Again, you can select, go back a little bit. You can select your own knowledge base items. You can correlate it already to pre-questionnaire to sprint questionnaires. So whenever somebody fills in the questionnaire, the items are being correlated and you get the right security requirements, so you can now define it yourself. So whereas the old security knowledge framework was really control-based because you got all the controls, now you can per team say like, okay, for this team, all the different stuff you're developing right now, these requirements are the biggest risks for this type of business and the functionality you're developing. And then can also go more to a risk-based framework instead of a control-based framework. So that's also pretty nice because if you're developing software, the software developers have really high pressure to deliver as much functionality as possible because the business normally only wants to see more functions because more function means making more money. So now you can eliminate more controls, move more to risk-based, and then you can make sure that everything with high priority actually gets picked up by your developers. So now you can create your own knowledge-based items. Here's the summary again, and here's the good part. So you can add questions if you want. And now, what you can see here is you get an overview of the different knowledge-based items which are correlated to different questions. So in the old security knowledge framework, we kind of defined the truth, right? We said like, okay, these knowledge-based items are correlated to these questions, and that's the absolute truth. No. And that's the absolute truth. So it wasn't really RFC for nobody. You couldn't really look into it unless you would really dig into the database and really would figure out yourself how everything was correlated, right? That's no longer true. So everybody can look into the security knowledge framework. For instance, they can go through the entire ASVS, and from there they can check like, hey, they correlated these questions to these security requirements. Why so? Maybe they say like, hey, I think what you correlated here doesn't really fit. I think you should change it from ABC to XYZ, for instance. And then it's RFC, and then we can have good discussions about how everything's being set up, right? So that's also really valuable. So we're not the single source of truth here anymore.
Yeah, so here what you see is we have a question, and that question we have the checklist, so it can be infrastructure as code or whatever you think it's a good set of security requirements. You select the question, and then the item that correlates to that question. So by answering this question, you can
like, hey, you need to do this then. Because the whole idea about the SKF is, to get context. That's where all the other tooling lacks. They have no context, and that's why they cannot say this is a vulnerability not. But by asking specific questions, you can get context, and because you have context, you can say yes, this is good or this is not good. So that is a bit of the logic that you're seeing here. And now you can add your own questions and cover one or multiple items from it. So, for example, the pre-item is more normally like covering categories. So like multiple items at once. Normally the sprint questions, it's looking a bit similar, but that's another phase, and those are more one-on-one. So verify that you are not susceptible for OS command injection or something like that. And then the question would be like, did you change or implemented system command functionality? If you click yes, I did, then it will correlate, for example, to the knowledge, to the security control of the OS command. So that's how you can correlate. 3 is normally for like covering multiple, and sprint is only one-on-one based relationship. So one of the questions here could also be, are you using template engines? And if the developer would have selected yes, he would have been informed about server-side template injection and how server-side template injection would occur. So even before he would start developing using the templating engine, he would have been informed. See, he would have been aware, and then he could act on it, right? Because you cannot act on certain vulnerabilities if you are not aware they exist in the first place. So the power here is the developer gets empowered and become aware before he even wrote a single line of code. So then, you can really make the application secure by design, which as a result, you do not create any technical debt, so you can iterate faster over your code, do more bug fixes, and ultimately create more functions, which makes your business dude happy, your product owner, and then it's all fine, because then, it earns itself back. So the same thing applies for, like we said, for the sprint questionnaire. It's kind of the same flow. Works the same way. Now, if we would go through the whole flow of the projects, we no longer only see ASVS, but you can effectively pick any checklist you want. And that's the whole power here. So you can create your own checklist, correlate the requirements to the right questions, and then per team have your own questionnaire. So you can have your own questionnaire for the people building the web API. You can have a questionnaire for people building the mobile application. You can have your own questionnaire for people building the infrastructure and whatnot. So every team gets its own specific list of security requirements, which really helps them making their stuff secure by design. And that's basically what Security Knowledge Framework is about. Because, like my brother already said, if we really empower the software developers and really give them all the context, then we can also tackle the logic flaws in the business logic, right? Instead of only, so now you have more coverage. So the whole idea is if you take the whole SDLC together, where indeed you have your security requirements, your normal test automation, because the code quality also says something about security, because if you have very over complex code, you will probably introduce logic flaws and whatnot, and your security test automation to defend yourself against the evil internet and all the automated attacks, and then ultimately at the final phase, the manual verification and the pen testing. And if you do all these steps in the SDLC, your pen tests also become very, very more valuable than they were initially. Because you can imagine if I come into a company and I do a pen test, and I find like 20, 25 findings only from my scan results, which take me like 20 minutes each to write a decent article about in my report, that costs you a shitload of money. Because then I'm reporting effectively 20, 25 vulnerabilities, wasting a lot of time. With reporting vulnerabilities you could have easily discovered yourself. So then when I come in and I do a pen test, I can really focus in depth on the business logic and all the hard to find sophisticated attacks, right? So it's also earns itself back by having more effective and good quality pen tests.
You're still not allowing me to be lazy.
Well,
What would you like to see then?
So I really like this.
uh-huh.
I have a friend of mine works for University of California Office of the President.
Mm-hmm.
Think of it as a consulting arm for UC California. Every campus can do their own thing, and so effectively you have him or a set of people spend the time, the
Mm-hmm.
cost to create some number of checklists and whatever the other thing is. They would then need to be able to export it and make it available to the
check.
Cs to be able to import into their system.
So basically what you want is an export function that exports the whole setup. So you want to do the work one time and then export it with all the questionnaires and the correlations and whatnot to import it in a different project, right?
Right. The other thing that's coming is machine learning and being able to do better security around machine learning, and that when at DEF CON this year there was a bunch of talks around that.
Mm-hmm.
It's a relatively hard problem that oftentimes could be served through a framework like this,
Mm-hmm.
because it's largely hypothetical. But then, because of its complexity, someone's going to want to be able to take it wholesale, like I don't know anything about machine learning,
Mm-hmm.
and want to be able to import that to the system, wherein there would be a repository on OWASP.org, or you guys can sell them, or someone else can sell them, or whatever.
Mm-hmm.
So I need you to empower me to be lazy.
Yeah, fair enough. I like that approach.
The whole export import, that is indeed maybe indeed a good feature. Talking about machine learning, by the way, we also did the Google Summer of Code project this year, and we gave the challenge to the students, because you could enroll for it, to participate, to build a machine learning chatbot on top of the knowledge of the security knowledge framework.
Absolutely.
Yeah, so all the knowledge in here, the knowledge base sections, the code examples, you can now ask like a chatbot. It runs on like Gitter, but it's also easy pluggable to Mattermost or Slack or stuff like that. Where you can ask the bot like, okay, tell me something about HCS, or tell me something about cross-site trustworthy. What is cross-site trustworthy? How do I solve it? Then the chatbot will select from the knowledge base items the description part or the solution part, depending on what you ask what or how, or you can also ask like, hey, show me the code example for HSTS in Java, then it will give that back to you. So that is also something that's in there. For example, in ING, we're now customizing it with also the jargon that we use in the ING company, like BIA, so it's like business initiated action, or IRM, internal risk management, or the specific company jargon stuff. So you just create a new knowledge base item, and you run the script for the machine learning chatbot, and it will pick it up. You can also ask questions about that. Currently, we have a bot in our Gitter channel that's being deployed and using.
This?
Let's see. And the funny thing is, so she also did a really cool write-up. So if you just want to learn about machine learning, there's also a standalone project of it. So here you have, for example, yes. So So here somebody asked the bot for code cross-site scripting, filtering, and Java, and the chatbot replied with the piece of code example. Let's see. Here, tell me about cross-site address forgery. Cross-site address forgery on REST, type of attack, and then how to solve. It will give you the solution part of this speaking framework of that knowledge-based item. So also this part you can reuse and.
Is that publicly available? Is it all deploying internally?
Like the whole project is indeed, it's all in the SDF class. And in there we have an API called chatbot, and you can post your questions to it. That is basically what this bot does, and that is being sitting in this GitHub room. It will just take the input, make an API call to, in this case, demo.security knowledge framework, because it's an API call in SDF that does the machine learning and selecting the answer then, and replying an API response. But if you run SDF locally, then you can point that bot to that local version,
So, it's giving an answer for that's all feature for the REST interface.
Yes.
Is REST interface here because that's based on earlier part of the conversation when I said that they're calling RESTful interface?
No, not that.
Okay.
So, good question though. Based on the machine learning and scoring, like page ranking and all types of algorithms that we use in the machine learning, it will pick the correct knowledge-based item from the list. Sometimes there are way too many to pick from, because, for example, cross-site request forgery comes in anything. Or here, somebody asks, what is injection? And the bot says, well, I know this injection, HTTP header injection, I know file name injection, I know dynamic scripting, I know file upload injection. So there's a whole list. So here you have a whole list, you get back, and then you just reply with the number from this list. So let's say I want to know number 5, that's the log viewing software code injection, and then it will return that part for that knowledge base item. So if it cannot score properly because, what is injection? It has multiple hits. It will just give you back the list and you can say, well, I want number 4, then it will give number 4 back.
Yeah, and I also know why you get the result for REST. Because there was a typo at that point. Because 2 of the knowledge base items, both the normal CServ and the CServ solution or description for REST, had the same title. That happens.
So that's basically the talk we want to show you, the security knowledge framework, a bit of the pain points that you have when setting up a software development lifecycle pipeline. That it does add value, but don't forget the human aspect of it. Really empower yourself with the right knowledge, the right security controls. SKF is there to help you. You can use it as is. Use the ASVS. You can say, no, I built my own script, my own checklist and controls. I guess that was it.
Yeah, well, I have one more remark. So if you really want to do stuff with the exploiting, so in the root of the repository you find this PDF file which has all the vulnerabilities which are in the target application if you want to exploit them all. Also our email addresses are in there, so if you cannot get stuff running or you're running into stuff, please send us an email, we're always happy to help.
And also you can join the GitHub channel. So you find that button on our SKF project. Because then you can just also come to the, what is it? I lost it here. You can just join the GitHub channel. If you have questions, we can also help you from here. So, all right, I hope you guys enjoyed it.